Good morning to all St. John's College of Pharmaceutical Sciences and Research, Kattapana. I welcome my 5th semester students for today's class, 25th July 2020. We have seen this is a continuation class of last Saturday, and we have discussed in the last class up to hardness of a tablet, how to evaluate by means of Monsanto, Pfizer and automatic machines which are available, and we just continue with the Friability Tester. So now the next step of evaluation of tablets, finished tablets, and also in process tablet evaluation, Friability Tester. So we want to discuss about what is friability and how the friability is tested by using this is the oldest, and also still we are depending on this Roche type of friability. The laboratory friability tester is known as Roche Friability. This device subjects a number of tablets to the combined effect of abrasion and shock by utilizing a plastic chamber that revolves at 25 rpm, dropping the tablet a distance of 6 inches with each resolution. So a pre-weighed tablet sample is placed in the friability, which is then operated for 100 revolution. The tablets are then dusted and are weighed. Conventional compression tablets that lose less than 0.5% to 1% of their weights are generally considered and acceptable. So see here in this slide, before going to the next slide, we should know about some of the things, that is especially dusted. It is still that first you have to weigh the tablet and you have to add to the friability or Roche friability, which is shown in the picture, and then you have to dust it. Dusted means it's not adding dust or something like that, because I am just making you to understand. So dusted means, for example, the tablet when it is used to rotate, or you are given as we are told in the slide, we are giving some abrasion and we are giving some shock by means of making the tablets to fall in the rotation movement of 100 revolution from 6 inches usually, not from very height, just 6 inches. It's also measured 6 inches. The diameter will be calculated in that circular instrument where the tablets will fall, or 6 inches, to give us shock. So why we want to see this? Why we want to see this friability test? Because this shock, this minimum shock and minimum abrasion should be should have the strength for the unit dosage form tablet to hold it. Otherwise, when it is transported, or when it is placed from one place to another, or which is shifted from one place to another, packing, there are many parameters which we have to do in the manufacturing unit itself. So there, when it is transporting or transferring from one place to another, and packing time when you are adding to machine, if it is loses many type of powdered, many type of constituents or many type of granules or any type of structural outside materials, if it is losing out due to the lack of binding or its consistency, your dosage will be differ, and also the tablet may become sometimes powder form. It will not be elegant for the patient to use it. So this is to control a second control over the tablet finished product evaluation. Even in process checking it is needed. In that place itself we can correct the tablet production and we can make the correction in the initial stage itself. So in process checking, friability tester is also very much important, like how you are testing the hardness of a tablet. So see here, just we made an video for you to just to come just to watch this video so that you will get an idea of what I said. And the 6 inches, see, you have to take first weight of the tablets. Here they have taken 10 tablets to be weighed in a digital weighing balance, and you have to subtract the tear weight, that means the paper weight, and only the 10 tablet, that is they are calculated, they are just calculated the 10 tablets weight. Even the paper weight will be subtracted and it shows that 5.455 grams for 10 tablets. And then next you have to wipe and you have to clean that plastic chamber which is of the Roche friabilitar. As shown, I have told you, you can see there, you can see my cursor also. See, there is a curve in the glass plate, not glass, it is a plastic chamber. There you can put the weighed 10 tablets and close it with the lid, and you can put the plastic screw, and also you can fix it to the shaft which is rotate, the revolutionary rotate shaft, and then you can fix it with that plastic knob which is shown in the picture. And then you can see that rotation you have just put on, and you are keeping, you need, according to the procedure, you need 25 cycle or 25 rpm by 4 minutes. If you keep according to the procedure, there will be 100 revolution will takes place. So we are just waiting for 4 minutes, only 4 minutes. This machine will rotate with the 10 tablets we have already weighed, that is pre-weighed 10 tablets is added to the instrument, and it is just rotating. You can see the video how the instrument is rotating for the friability test. So you see, after 100 revolution, it will be automatically, it will stop. The machine is already, we have fed how many revolution you need and how many minutes it has to, what is its RPM, and then afterwards you have to remove, you have to stop the machine and remove the tablet, and what you have to clean the tablet. After that the same tablet is removed and you have to clean it, that means not clean it, dusting, that is what it is written in the previous slide. I told dusting off. Dusting off means if suppose something is which has come outside from the tablet, and dusting off, remove, and then again weigh the tablet. After dusting the tablet, you weigh the 10 tablet again, and now this is this weight, tear weight should be subtracted, only the tablet weight you have to take, and there will be lot of losses will be there. So you have to see how much, what is the weight of the same 10 tablet, and then we have to see the difference between the initial weight of the 10 tablets and after using in the friabilitar, after the 100 revolution in the friabilitar, after giving the shock and as well as the abrasion which has been caused by the 100 revolution by means of 25 rpm per minute. That difference in the weight will give you the loss of tablet constituents or tablet particles or tablet granules which is in the from the tablet, the loss is that gives the percentage of friability. So that the initial weight minus the final weight, the difference divided by, you can go for the initial weight, and into 100 you will get the percentage. So usually 1% is maximum. Here you can see it is only a 0.1%. When you calculate, it is a 0.1% is coming. So it is an acceptable tablet. So it is an acceptable tablet according to us. It is an acceptable tablet. So next slide, when you come to that, now the question is, now our question is, okay, we have checked the friability test. By means of friability test have been performed by means of using this Roche friabilitar, and why this friability is taking place, how we can control. The pharmacist should know the defects and as well as the complaint, as well as he should know how to solve it also. So once you know how it is happening, how it comes to the its tablet, then you can go for its solution also. When concave and especially deep concave, and deep concave. Concave means you may be knowing concave, convex. Why this concave and convex it comes to play in this compression machine or in the tablet? You can see tablets are not what we have seen in the video is straight tablets. At the same time, there will be concave and convex type of tablets are there. Sometimes tablets will have concave tablets, convex tablet. So if you need a concave tablets, what will be the structure of the punches? You see, there is, as we discussed, there is two punches will be there. One punch will be lower punch, is I have told it's a pencil actually. You can see my video, it is a pencil. Just to show you, I'm just because I don't have the instrument to show you now. You can see this is a pencil. You can imagine that it is a lower punch and it is upper punch. The die will be here, die is not shown to here, and it will be passing through the die. So in between the powder will be kept, or the granules will be kept, and you will compress, and you will then after tablet forming it will be ejected out. So you can see that if the base of the punches are flat, and you will get flat tablet. Suppose if the base is concave, you will get convex type of tablet, that is discoid tablet. Tablet will be little curved in the top. Suppose if it is it's a concave type of, concave means it is a open concave. Suppose if it is a convex type of punch, then you will get concave type of tablets you will get. So what they want to say is deep concave punches. Suppose if you are having deep concave punches and you are preparing some convex type of tablets, usually the curved tablet, both the sides curved ovoid shaped tablets are more common. So concave type of punches will be there because the powder will go inside, you will get the shape of tablets slightly not flat and curved. So that is that curved type of tablets, when you are making this type of problems will come. Why? Because there will be sometimes the punches will, if suppose poor maintenance, rusting, and also we are not after punching, the operator should clean and it should be kept properly by means of, and then next time you have to do maintenance should be there. If there is a poor maintenance, there will be worn will be taking place. What do you mean by WOR and worn? Means some small, very minute microparticles might have removed from the metal of the punches. So if it is a particle is removed, there will be a gap. So it will be a micro. So when you compress a tablet by lower punch and upper punch, if the punches are worn somewhere, what will happen? There will be some, if there will be some particles will be extra, will be stick to the tablets while compressing. It will be strong only. So, but when you come to outside, when you are taking to transporting or something, the friability will be increased because that powder that will come outside, and so that it will be even it will be doses may be vary. So the friability should not, that is due to the edges may be worn in the punches are one of the biggest issue, one of the biggest problem usually occur. Because you can see this, for example, if you are not able to understand what I am saying, always we have to make yourself understand by means of comparing with what is happening in our normal life. You can see biscuits or some snacks or some cookies when you are purchasing from the local market or a bakery. If they are using some mold or some seal, some mold when they are using, if the mold is having some different types of crack or something, the crack will come in the snacks which you are purchasing. The biscuits also will, the design will be differ, and sides will be having some whiskering. So whiskering is called whiskering own. So whiskering of the tablets will make that extra some things will be stick to that the materials due to this the edge problem and due to uneven problem of punches or the mold. So such tablets are higher than more normal friability value because of viscous are removed while testing. So viscous will be always removed because it cannot withstand with the tablet for a longer period, because you are giving some 100 revolution and also with some shock when you are making it to fall from 6 inches. So automatically it will lose, and the friability friability tester will have more percentage. So the tablet friability may also be influenced by the moisture. Next one, not only the whiskering of the technical problems, this is also another one. Even by means of manufacturing, when there is manufacturing, and also the nature of the compound will also have influence for this type of friability, and also the texture may be changed with the tablets while transporting. So this friability will increase. Why? Because influenced by the moisture content of the tablet granulation and finished tablet. So a low but acceptable moisture level frequently act as a binder. That everybody knows. Even when you are using to prepare chapatis or any type of preparation in your home, we used to add water, or we used to add some solvent. When you are adding some solvent, usually powders will have a tendency to make it as a binder. So binder, another starch, also starch paste which we are using as a binder in the tablet manufacturing, but still water or a solvent also have moisture, is also having a tendency to have a binding agent. It is also will act as a binder. Very dry granules, for example, when you are using very dry granules, contain only fractional percentage of moisture, often produce more friable tablets than do granulation containing 2 to 4% of moisture. So for this reason, the another point which I have underlined, the manufacture of chemical stable tablets that contain some hydrolyzable drugs that are mechanically sound is difficult. So for example, to make mechanical strength, to give a strength to a tablet which contain a hydrolyzable chemical substances or drug substances, it cannot withstand the strength of the tablet hydrolyzable, because it will take the moisture from the excipients and inside the drug, and also it may be utilized, and also it will loses its texture and the hardness, or it will brittle, and so that the tablet may break. So physicochemical properties are very important before handling with any type of manufacturing drugs, any type of formulation which you want to make. Physicochemical properties of the active ingredient as well as the any excipients when you are adding is very important, and it plays a major role for your all procedures. So this is just a picture I have taken of all the instrument which we are going to discuss today, especially Roche fibrillator, Fryability, and next we are going to discuss about tablet disintegrator tester and also dissolution apparatus. So here comes this two, that is friability. When you finished, we are coming to next step is disintegrator and dissolution. So disintegrator and dissolution, you should know that what is the difference between disintegration and dissolution. What is disintegration? What is dissolution? If you know that, then it will be easy for you to go into this chapter, and this section will be easy for you. So disintegration means, what is disintegration? So tablet is disintegration means when you are putting or adding when you are taking some tablet in your mouth, and when it reaches to the stomach, it should disintegrate, then only it can dissolution. So very simple to understand. When you want to solubilize any substance, it is needed for you to pulverize them, or to size reduction is very important for the solubilizing very easily. Because you know, stomach, when you are taking half an hour, or intestine half an hour, within half an hour anything if you give, it has to be dissolution, it has to come to a dissolution stage, then only the absorption, and it will come to the bloodstream and it will give the action. So that is why first one is disintegration is very important, and then dissolution. So disintegration and dissolution is having some difference are there. And what is the main difference? For example, a substance which is very fastly disintegrate, it is not necessary it has to undergo dissolution. So it has some its own physico-chemical properties. So it is also very important. So disintegration is different and dissolution is different. Disintegration time is also very important. At the same time, dissolution is very, very important for the drug action and also the therapeutic action of any active principle which is added in the formulation. So that is what the different, what is the disintegration means. Any drug or any substances that disintegrate, breaks into smaller pieces for ready for dissolution. So the pre-action or the before pre-action before the dissolution, before dissolution, the first step is disintegration. Even in your pharmacology also you might have discussed about the kinetics. When you see pharmacokinetics, you might have studied any drug which is taken in the oral route. First it has to undergo disintegration, then comes dissolution, then comes absorption, then comes metabolism, then comes excretion. So before absorption, the very important is, before dissolution also very important is disintegration. So disintegration, dissolution, absorption and metabolism, then excretion. This is what you might have studied in your pharmacokinetics. So that is the difference between the disintegration and dissolution. And also before going to disintegrate our instrument, we should also know about the weight variation is also one evaluation very commonly we used to use to do in the in-process checking, and also it is also checked in the quality QC control and quality assurance department. So in the United States of Pharmacopoeia, weight variation test is run by average weight and comparing the individual tablet weight to the average. So you see, it is very, very important. You have to take 10 tablet and find out the average weight, and also you have to take the individual weight of the tablet. And USP, United States of Pharmacopoeia, says that no 2 tablets to meet the outside of the average, 10 tablets average. It is very, very important. And the percentage limit is also, if no tablet, even single tablet should not differ double, that is more than 2 times of the percentage limit, it is also not allowed. This is the limit which is given by the monograph and the specific standard book, United States of Pharmacopoeia. These type of limits are also available in every pharmacopoeia according to every industrial, every pharmacopoeia, especially in Indian pharmacopoeia, you will be having the same limits, and also we should follow the same thing. And the weight variation test would be a satisfactory method of determination of the drug content uniformity of the tablets were all essential 90 to 95% active ingredient. So it is necessary, even it is not possible only one word in a one single word. I have just finished with this slide, but it is not an easy step. You can see drug uniformity and the content is not easy to find out. You need to go for analytical chemistry, and also you have to find out the drug, whether what type of analysis, what type of, how to find out the concentration, what is the label claim. If the label claim is 200, it should have 200 in all the batch, all the tablet. One tablet 150, one tablet is 250, one tablet is 200, one tablet is 170. It is not at all allowed. So always it is having a parameters. The weight variation test would be satisfactory method of determination of the drug content uniformity of the tablet where all essential 90 to 95% active ingredients should be present. This will be analyzed. And now we are coming to the two things which we have discussed, and first we will discuss about the disintegration tester. So any tablet we have to undergo disintegration tester, and also you see for a tablet, if a drug is to be readily available to the body, it must be in solution. That we know very well. It's a general point. So the important step towards the solution, it is to break down the tablet into smaller pieces or granules and to process known as disintegration. This is what it told, into smaller pieces. And the time that the device described in the United States of Pharmacopoeia and NF, that means British National Formulary, the majority of the tablet have the maximum disintegration time of 30 minutes. So maximum. So it is not a maximum, it's not 30 minutes. So before that, it usually they will disintegrate when it enter into the stomach. It has to be. And there are commercially available disintegration and dissolution apparatus. Most pharmacists will not have this equipment. However, a simple disintegration apparatus can be made. Start by supporting 10 mesh screen about 2 inch above the bottom of the 1000 ml beaker. Fill the beaker with 1000 ml of water and a stir bar and place the beaker on a magnetic stirrer plate. So stir at a moderate speed, drop the tablet into the mesh screen and record the time needed for the test to disintegrate. A reasonable disintegration time should be between 15 to 30 minutes, although the time will depend on the product, the stirring speed, etc. So you see, this is, I just gone through and read the what is given in the slide, but anyhow it is very simple for you to understand. So for example, there are machinery with attached with a computer and you will get the printout, but you know the technology behind what is the necessary we have to do and how it is performed. Even all the technology, how much it is increased also, the basic principle will be the same. And basic principle is how much time it takes for disintegration. So what they are doing is 1000 ml beaker which is filled with water, and also it is maintained in certain temperature like GIT, gastric juice, and also 37 degree centigrade plus or minus 0.5 degree centigrade should be maintained as body temperature, and also buffer solution also we have to use as to maintain the same pH in the stomach. And also you have to make sure that it should have, the tablets will be kept in a mesh, that is 10 mesh size. That is 10 mesh size means there will be a mesh. You can see that is, you might have studied in your pharmaceutical engineering last semester, stating that various sieves and also size reduction, after size reduction, sieving, powder size, and also you might have studied it is measured by mesh. 1 square inch, how many pores are there, according to that number of the mesh is given. So 10 mesh, 12 mesh, 16 mesh, 80 mesh, 60 mesh, 100 mesh, 120 mesh, 150 also is there. So when the number is increased, automatically the size of the powder, the fine powder can be sieved and separated, because the number increases means the meaning is 1 square inch has how many pores. If the pores are more, the number is more, the pores are more, then the size of the pore should be small to cover this 1 inch of the square inch. So that is the main principle behind which you have studied, and that type of the 10 mesh will be kept and the tablet will be kept over, and this cylindrical vessel will be moving through the 1000 ml beaker which contain the water bath, and the temperature will be maintained. And there you can see, by means of the upside down movement, you can cause even abrasion by means of keeping some beads, or you can keep some plastic disc over the tablet, so that it will move in the water only. It should not come outside the water. So that shape, all that is the distance also will be maintained, so that you will get disintegration. The time will be absorbed. The disintegration will be absorbed by manually by means of the neck, by your eye, so that we can mention how much time it takes for the disintegration. And this is what I have told the distance. You can see a picture which is shown below here. You can see my cursor which I am showing. This is the tubes, and here it is shaded. It is to go, and this is all the 6 tubes, and also the base will be having a mesh. Actually 10 mesh will be there, and 6 tubes. How long, and what is its capacity, and also how long it should move in the water is given in this slide. You can see here the United States Pharmacopoeia device to test disintegration use 6 glass tubes. This type of 6 glass tubes. You can see 6 glass tubes, and 3 inches long, open to on the top and held against the 10 mesh in the bottom. You can see the shaded in the bottom. You can see the 10 mesh screen in the bottom and the end of the basket rack assembly. To test the disintegration time, 1 tablet is placed in each tube. So 6 tablets can be kept in the basket, around that basket, and positioned to 1 liter beaker in water. And stimulated gastric fluid is actually stimulated gastric fluid or stimulated intestinal fluid at the temperature of 37 degrees centigrade plus or minus 2 degrees centigrade, or usually plus or minus 0.5 degrees centigrade will be maintained, and such that the tablet remain 2.5 centimeter below the surface of the liquid, and not the their upward movement and descend to the closer than 2.5 centimeter from the bottom of the beaker. So bottom of the beaker also, it should not go and touch the beaker of 2.5 centimeter, it should not break, and also the level of the liquid, it should not go above the level of the 2.5 centimeter above also. So it can be, you can see the what is the distance traveled by these two places is 6 to 7 centimeter frequency. There is 6 to 7 centimeter frequency is same like peristaltic movement we are giving to the tablet, how it is the same like the movement which is taking place in the bowl, so that it will be you are getting the correct disintegration time for a tablet when it is given in through GIT. So you can see here a standard, you can see even a standard motor device is used for moving the basket assembly containing the tablet up and down through the distance of 5 to 6 centimeter at a frequency of 28 to 32 cycles per minute. So this cycles per minute 28 to 30, not very fast also. So that is also controlled by means of parameters which is given 28 to 32 per cycles per minute. And perforated glass plate discs may also be used in the test. The disc, perforated disc, can also be put over the tablet. You can see the video, the second video, when you see there will be red color perforated plastic disc we will put over the tablet to give an abrasion to the tablet, so that it gives the same atmosphere when a tablet is taken in the bowl or in the GIT, so that it can be easily identified for how much time it takes for disintegration. These are placed in the top of the tablet and impact abrasion action or to the tablet, talking about the disc, that is perforated disc. And this is the video which you can observe. And so that we'll here only they did not have the disc, they forgot to put. You see, this is a normal Panomex and easy to operate. It has a water bath and having a coil, and there are two shafts which you can see that, which is the holders for the basket assembly. This is, you are to make the water up to the water level which they have mentioned in the instrument, and then you have to keep 2000 ml beakers, 1000 ml beakers, as we have seen in the monograph. You keep the 1000 ml beakers here and pour water inside the beaker also. Pour water inside the beaker, because the beaker water or the gastric fluid, actually gastric fluid, the water is inside the chamber, this is gastric fluid or a buffer, it is gastric fluid they used to maintain the ringer solution, so which will be equal to the gastric fluid. And then you are taking, this is the basket, you see there is 6 long tubes and the base is actually with mesh, will be kept inside the 1000 ml beaker which contain the gastric fluid, and then it is connected with that particular shaft which is coming from the holder, which has the provision to have an upside down action, and also down and up action will be there by that shaft, which is, then it will be tightly, and it will be, both of them will be in the same position, and also the height will be same maintained, and so that it will have an action of upside down action by the shaft which we can see. And then we are taking one thermometer, that is temperature probe, which is a side of the machine, you have to fix it, which should be, and there is an electrode which should be kept inside the beaker near to the sixth chamber, any one sixth chamber, it should be, there is a holder and there it will be kept, so that it will give what is the temperature. You have to maintain the temperature of 27 degrees centigrade, and this is the water, you have to give water inlet for the water bath, and also it can be it is outlet, and also water can be, even if suppose excess water is there, it will be removed, because the level should not be more. And this is the jack which is used for heating the water bath. Water bath will be also heated separately by the coil. And another is one which was for the digital action, and also other various machinery power plug is also a jack which is fixed, so that when you put the switch now, after increasing the water, after first you will get the screen, that is heater, switch on the heater. So you have to switch on the heater and you have to maintain up to 37 degrees centigrade. So up to that, now you can check that what is the temperature which is shown, and also you can feed, it is showing 29.4 degrees centigrade. So you have to, that is the heater is on now, and when it comes to 37, when you are feeding that, it is 37.1 or 37 what to whatever you have fed, and immediately it will off, and so that the heater will be maintaining the particular temperature plus or minus, it is 0.1 0.5 degrees centigrade will be maintained. And also setup, you have to go for name of the drug which you have used for finding out the to find out the um, disintegration time for the tablet finished product. So that is also, you can maintain the name, you can feed the name, and also you can now it is off because 36.5 degrees centigrade which you want to insert, and now you have to insert that sample. I see that that pharmacist, he is just adding all the tablet in all the 6 glass tubes which were the top is open, and also bottom is with a sieve or 10 mesh, and you can see, you can put the tablets inside, and even after putting the tablet, it's necessary for you to add a disc, plastic disc, for to increase the abrasion, but here it is not shown. We will see in the next slide, and then you can see he will fix the time, and then you can see that it will be moving. Can you see that upside down and moving of up and down movement of the cylindrical, and you can see the cylindrical basket which contain the tablet, and you can see that how it is going up and down, and the level of the water should be maintained. Here the level is not maintained even in the beaker. It is a he has not maintained the beaker, it is going outside the level of the beaker liquid, so it should be maintained. And when he saw that completely disintegrated, then he will go for the off, and also you can go for printing, and you can clean, and you can keep for the next step for next experiment. So this is what the Panamics type of equipment for distillation for disintegration technique. And this is the test is over, and you will get a print, and you can just go for the next experiment. And you see the next slide, this is one important instrument which is produced by Lab India, and it is an advanced, that is not Lab India, this is Pharmatron, sorry, Lab India is another one. This Pharmatron is also produced an instrument which is having, see that how the tablet is getting automatic. This is the 6 tubes. See, this video I am showing is to make the students to know about what is the 6 tubes, and bottom is covered with a mesh. You can see the 10 mesh, and after that he is putting a red color, that is called round red color, which I told. You can see that, even I did not explain, you can just see that red color, you see the red color bead, like what he is putting is the disc for over the tablet to get abrasion or to get the friction over the tablet, like same type what is the feeling in the peristaltic movement which takes place in our GIT. So then you can feed the name of the drug and everything, and you can select the timing, and also what is the cycle of needed, and you can have the 1000 liters of water, not water, it is that is the gastric fluid, where even buffer solution with the pH of gastric pH can be maintained. And then you can see that how it works, extremely short heating time, well inducting this time, that is 3 to 5 minutes, and ambient heat temperature. And also you can see when it is showing the green color, it is ready, and automatically if you fed that 37 degree temperature is maintained, automatically test will start after the temperature is maintained. You see that, you can just watch that the tablet disintegrate very fast, and also the time will be immediately noted by manually, and also the machine itself, they will know. See how much it just goes on, goes on, and you see now it starts, slowly, that side, this side, and everywhere it is slowly, it is started disintegrating. And you see this is the point of time. So this is the time, that is 2 minutes, it is 1.54 minutes is necessary for complete disintegration takes place. Now it is completely disintegrated, it takes place 2 minutes. So you can see this can be easy and fast handling, and not only one this you can see again they are shown, that is 6 tubes, how it is open, both the sides are open, only in the bottom you are keeping the mesh, and this can be fixed with 1, 2 and 3 and 4 also can be fixed, and you can go perform the experiment for 6 means 24 tablets can also be analyzed in at a time. So this is about the disintegrator, and you can see now we are coming to dissolution. So when you are coming to dissolution, what do you mean by dissolution? Can you say about dissolution? What is the difference? Already I told you there is a difference between disintegrator and dissolution. So a tablet which is disintegrated, it is not necessary it should be undergo dissolution. So dissolution plays, and also dissolution is very important, which is connected with the action of the drug. As I told it, after dissolution only the absorption will take place, and dissolution is a deciding factor to how much amount of the solution tablets or how much amount of the active ingredient is released to the bloodstream for their action, therapeutic action. So dissolution is a very important point and important factor, and how to find out. So dissolution is finding out the release of the drug from the tablet formulation. So disintegration time, see whatever I have told, it is written in that points also. You can see disintegration time determines it is a useful tool for production control, but disintegration of the tablet does not imply that the drug has dissolved. Disintegration, it does not. For example, disintegration time determines a full tool for production control, but disintegration of a tablet does not imply that drug has dissolved. So a tablet can have a rapid disintegration time yet be biologically unavailable. Even though a tablet is very fast in disintegration, we cannot say the tablet is biologically it will not be available. Why? Because it has to undergo dissolution and absorption. So the dissolution rate of the drug forms is the primary particle of the tablet is an important factor in drug absorption. And for many formulation, it is a rate limiting step. It decides the rate limiting step. The dissolution rate gives the decision for release of the drug, and release of the drug will give the decision for the action of the drug or therapeutic action of the drug. So this is rate limiting step. Therefore, a dissolution time is more inductive of the availability of a drug from a tablet than a disintegration test. So dissolution test, we can see that it is again we have made it, it is a big long process, but still we are making into the different types which is available. The two objectives in the development of the in vitro dissolution test are shown. One is that the release of the drug from the tablet is as close as possible to 100%. This is very important point. See, for example, a tablet which you produced, it is 500 milligram of paracetamol or 100 milligram of diclofenac or any 500 milligram ciprofloxacin, anything if you produce or anything if you manufacture, if you formulate, you are intended for the dose is intended for the drug action. Am I right? So when you are preparing some tablets formulation, it is must the tablet 100 milligram, it is denoted in the label claim 100 milligrams should be released to the bloodstream and there should be action. So 100% release should be there, 100% dissolution tablet should be there. That is why we need this dissolution tester should have. And number two, the rate of drug release is uniform batch to batch. Even one batch and to another batch it should be same. So randomly you have to take not one tablet by decision of the dissolution rate will not give you the answer. So random a number of tablets you have to take, a uniform weight you have to find out, and then the label claim, and then you have to find out the release. How to find out the release? And you can see there are any equipments which is given how to find out the release. The time, that is time can be denoted. Every intervals you have to take the samples of dissolution and you have to analyze how much amount is released from the original formula. And United States Pharmacopoeia 25 and that is, and also the national formulary, British National Formulary 25 and USP 20 or you can see supplement 3 specified and early of 2 apparatus be used in the determination of dissolution test. So here you can see the apparatus 1. What is the difference between apparatus 1 and 2? You can see the picture. In apparatus 1 means you should remember it is a basket type. You can see the picture which here, you can see my cursor I am taking there. There is a basket, inside one dark tablet, just to show you a dosage form is added to that particular basket, and the basket will be rotating. It will be rotating and you will be having a rotating for motion, and the solution will be having the 100 ml beaker. It is a 100 ml capacity beaker which contains a solution of gastric fluid, and also the intestinal pH will be maintained, and so that it can be temperature can be maintained for 37 degrees centigrade plus or minus 0.5 degrees centigrade. This will give you the more atmosphere of the tablet in the stomach or GIT position, and so that the dissolution rate after rotating every 1 minute after starting the instrument, every 1 minute you can take a continuous withdrawn an interval of samples, and it can be determined for the content of the drug, so that you can find out what is how much release it has been taken for 1 minute, 2 minute, 3 minute, up to 30 minute, even above that also can be determined. And this is what happening in manually, but it is a difficult job, but 2-3 you can do it 1 or 2 times, it is possible. Previously also we have done, but many automatic machines have been now automatically they will take samples, and also once you take 1 ml or 2 ml or 0.5 ml or 0.1 ml when you take from the flask, it is necessary for you to replace that particular solution. Also you are taking the gastric fluid, it should be replaced by the gastric fluid in the same beaker. Then only the next sample when you are taking the dilution calculation will be done by the pharmacist to give the concentration release in 30 minutes. If in 30 minutes 100% is released, it's a very good tablets, because tablets can within 30 minutes it has to release all the drugs which are present in the tablet, so that it will be absorbed and it will maintain the minimum effective concentration, and you will get the pharmacological action. So here a single tablet is placed in a small wire mesh. So this is first apparatus is a wire mesh type, a basket type, mesh basket. First end means first end. It is fixed in the bottom of the shaft which is shown in the picture and connected to the variable speed motor. The basket is immersed in a dissolution medium. So what is a specific in the monograph? As specified in the monograph, the medium will be prepared by the monograph. They used to say for some tablet where in intestine or in the stomach, according to that you have to prepare the solution, and also you have to maintain that particular liquid, and containing 100 ml of flask. The flask is maintained at a temperature of 37 degrees centigrade plus or minus 0.5 degrees centigrade by a constant temperature bath. The motor is adjusted to turn at the specific speed, and the sample of the fluid and the withdrawn as at intervals to determine the amount of drug in the solution. So it is written that at intervals, withdrawn in at intervals. That means every minute or every half a minute or every 2 minutes or every 5 minutes they will take the sample, and also they will test it for the content. Content testing is not very easy to say. So for example, according to the sample of the drug, it will be going for the testing. Usually it will be connected with HPLC, and you can separate the compound, and you will get the compound by means of UV spectroscopy, which is the detector which can be usually found out in the HPLC apparatus. So that will be giving the detection. This compound is having this much concentration. So when the concentration, we can find out the calculation in 5 minutes how much, in 10 minutes how much, in 20 minutes how much, and in 30 minutes how much have been released, and this gives the release of the drug of 100. What is the percentage of the release of the drug can also be determined. And also you should know that what is the T-half. T-half means 50% of the release and also 90% of the release. As per the United States Pharmacopoeia, 90% of the release should be done within 30 minutes. Otherwise, these tablets are not releasing properly. It will undergo in the feces. So it is very important for anyone to note it down. What is the release of the drug is very important, and that is why we are talking about dissolution test is a very important parameter or important evaluation of a tablet or any formulation. Otherwise it will the concept behind the drug manufacturing will be completely destroyed, because the concept behind drug manufacturing is for disease, curing the disease or curing the particular pathogenic action towards against the particular pathogenic infection or any type of pharmacological action. So this pharmacological action will be depending on only by the release of the drug. Once the drug is 100% released to the the bioavailable in the blood, then only you will have the minimum effective concentration for that particular action. So you see the picture very clearly, basket type and the vessel, and you can see sampling where you have to take the sampling point also even mentioned in the picture. There only you have to pipette and you have to take a sample, or in automatically there will be some tubes will be inserted. If you see in India lab equipments, the Lab India equipments, they are having very good equipment which is automatically sampled and connected with HPLC, and you will get a printout of all the things whatever you have done, and so that it is easy for you to find out, and also monitoring the manufacturing unit, and also in process checking, and also quality assurance can be given by means of this type of equipments, and very important for the analysis for the pharmacist. And the apparatus too, the first one is basket, and apparatus 2, the same equipment as in the apparatus 1, same equipment, only thing is the basket is replaced by a pedal. You can see the picture, pedal blade, and also you can see there is how the shaft it is fixed, and the medium will be poured there, and you can keep the tablet down, and also there the tablet is kept inside the basket. Here the tablet is kept inside the down to the pedal, and you might have studied this pedal type, all these things when you are studying in last semester, like you might have studied that pharmaceutical engineering, in that size reduction, that is pulverization, and then mixing, crystallization, many things you might have studied in the smaller. So after size reduction you might have gone for mixing. In mixing also you might have studied solid mixing and liquid mixing and semi-solid mixing, various mixtures you might have studied. So in that baffles, pedal type, and also you might have studied blade, different types of blade. This is blade with a pedal which can be used for this purpose, and there is some specification also given by the monograph of the IP and also BP and the United States of Pharmacopoeia. So that will be followed, the specification, and in the use of except the basket is replaced by the pedal form from the blade and the shaft, and it is stirring element. And industrial pharmacists routinely test their formulations for dissolution, not only tablet, capsules, many other formulation also. Dissolution test is very important to study about the release of the drug. And T-half, that is, for example, this results a plotting of concentration versus time. When you this plotting in a graph, you will get T-half. That is 50% of the drug, how much time it has taken for release, and 90% of the drug, how much time it is taken for the release, can be easily calibrated by means of graph, by means of using y-axis and x-axis, by plotting the time versus amount of drug release by the sample which you are analyzing, and you can find out 10 minutes, 5 minutes, or 15 minutes, 20 minutes, and 30 minutes or 40 minutes also we can identify, and the percentage dissolved in 30 minutes are used as a guide. And you can see the value of T50% is the length of the time required for the 50% of the drug to go into the solution. A value of T90% is 30 minutes is often considered as a satisfactory and is an excellent goal, since a common dissolution tolerance for United States Pharmacopoeia and British National Formulary is not less than 75% dissolved in 40 minutes. So 40 minutes, in 45 minutes you can see even it is 75% is not, even it cannot release, means it cannot even release any, there will not be any action, it will be taken back to the, taken away to the feces and it will be excreted, so that it should be maintained according to the monograph and according to the BP, according to the United States Pharmacopoeia and Indian Pharmacopoeia, what they are saying, it is necessary for to maintain for any drug to satisfy the dissolution test. So you see this video, so that it will give you some idea. There are two videos. This is a College of Rajeshwari College, which the MPharm student who have just shown a old model, and you can see this is a old model dissolution test apparatus, and it is by means of manual technique. So anyhow, this is available in our college institution also. When you are coming to the St. John's College or in our college, we will just observe this dissolution test in our machine room, and we can operate also. So you can see that this is the dissolution apparatus, and it is made up of electro lab, and you can have many operation techniques. And first we have to select the program, and what is the tablet, even you can feed the tablet, and this is what she is explaining about the 100 ml capacity of and then she is putting the tablet inside, and then she is just putting on, and the pedal type is fixed in that handle, and then it will start rotating. Once she is fixing the rotation speed, revolution speed according to the monograph what they have given, you see that how the pedals are, the shafts start rotating, and then once it is started rotating, after certain time immediately time is also calculated. After 1 minute you have to take, there are many flasks, you can see the standard flasks are kept ready for taking the samples and dilution, and also you can see you can use the pipette, and according to the procedure you can take 1 ml or 2 ml. Calculate the amount is very important. You have to take 1 ml or 2 ml according to the procedure, and take that and sample to the standard flask, that is the standard or volumetric flask. This is a 10 ml volumetric flask, and this 10 ml volumetric flask she will be having the dilute, and then this sample will be taken for UV spectroscopy or HPLC, and then or you can even go for complexometry titration or iodometric titration according to the sample which you are using, the tablet which you have taken, or the active ingredient which is present in the particular formulation which you are going to find out the dissolution test, and that can be identified for various tests by means of using the instruments or a calculation how much amount is present in 1 minute, 2 minute, 3 minute or 4 minute or 5 minutes can be calculated. So this is a simple procedure of the video, and I have taken another video which is the new technology, and also it is produced by very innovative, and also it is an interesting technology which is produced by Lab India, and Lab India is a very good instrument which is automatic, fully automatic. You see the tablet will be placed inside and how it is rotating. Just this video will be having some interest for you to see, and there are that this is connected with even the automatic sampling system, and also it will be taken to the HPLC and it gives the printout what is the concentration which is present in it, and it will be very easy for you to identify. See this is the screen, and in this apparatus it displays all the things with a crystal display, and you can see this is then he is fixing, this pharmacist who is fixing the shaft of the pedal type, and the height is also denoted, and everywhere it should be kept in the same height, and it will be denoted after fixing every pedal type. And even this is, if you want to have basket type, you can fix basket type. See that also he has shown, and you can see that is afterwards you can fix it by means of automatically. This is the gastric fluid which is already prepared, and it will be entering into the Lab India instrument, and automatically it will enter into the all the this chamber, and you can see that solution will be kept, gastric fluid solution will be kept, and also you are keeping 3 knobs inside this. One is pedal, another one is temperature controller, another one is, you can see there is three, you can see, just a minute, you can just see there is 3 knobs are there. That is what he has shown. You see here, now we can see that is, I put a pause, you can see this one is the pedal, and this one is a sample sucker, samples will be taken by this, and this one you can see there is an temperature controller. So every chamber, every beaker, as we have told in the previously, every beaker or the round bottom beaker which will also operate in this manner. So you can see when you put the switch, this pedal and as well as the sensor will also together, they will come into the place, and then once you are feeding it, you have to take the sample name, and you have to keep the name of the sample, and what is the revolution you need, and what is the temperature you need. All these things you have to, this is a prednisolone, his tablet, so they are just adding the name of the sample and prednisone, and also you can see according to which procedure you are going to do, and buffer volume, how much you are taking, and also it can be used 100 to 1000 ml, and according to that how much the ml is more, according to that you have to calculate the sample withdrawn, also you have to calculate how much ml you have to withdrawn, and what is the dilution which has to be taken for even taken for the HPLC plant, and so that you will get a very good result. These all things very important. The parameters, temperature, even temperature, what is the maintain, and buffer solution formulas, everything you will maintain, and it will be given even in the record. It will give the printout, dates and the time, which also can be added. And once you start, it will say now it is a sample. Insert the sample, they used to say. You can see is not the test 1, test 2, like that also you can. And where check the sample assembly, it says sometimes if you are not fixed properly, it will tell you to check, and after fixing properly it will automatically start doing. And intelligent sample system it is. You can see there. See, now also I am just putting the pass to make the students to know. Here pedal, and here you can see sample probe. It is clearly, it is shown in the video, sample probe, and this is digital temperature sensor. See, pedal, sample probe, and digital temperature sensor is also there. So these all comes inside the chamber, and that's why you can just maintain, and you can see that all the pedals started working, and immediately you can see that, and now it will give the information. You can introduce the sample. Now you are introducing, see, in all hole provided for the sampling, you just added, and once the sample enter into the round bottom beaker, and you can see next it will automatically start, and this will give the atmosphere condition of the movement in the intestine, what is the temperature maintenance, and how it undergoes dissolution. And these tubes are shown for example sampling. It will take the samples automatically. Every minute means every minute, every half a minute means every half a minute, every 2 minutes means every 2 minutes. That is decided by the operator, and then when you fed that, you see how the sampling is taking place automatically. You are, instead of pipetting, it will give exact amount. If it is 0.1 ml means 0.1 ml, 0.5 ml means 0.5 ml, 1 ml means 1 ml. It will automatically, it will bring to your test tubes or in your standard flask, so that it will be taken for the next step of HPLC for identification. You can see this is on HPLC vial which is available, so that this vial will be directly shifted to the HPLC, and so that you can find out the concentration of the solution in 1 minute, 2 minute, 3 minute, like that, and you will get the printout of every minutes and how much the samples have been connected, isolated, and you can find out the release very clearly. So that is what I want to say here. You can see the slides, and this is somewhat the instrument backside jacks, and also this is the whole instrument, and you can get the display very clearly, and it was very simple and automatic, and once you maintain properly you will get a very good result by this. There are additional features are also seen in this instrument, and that is the about this. And also next slide, now we are coming to the last stage of this class, telling that analytical determination of tablet content. That is also very important, but only one slide I have shown because it is in analytical chemistry part, and which we are going to study more detail. Anyhow, we have to know what we are going to do. The weight variation of the tablet already we have discussed, can be measured by weighing the individual tablet and determine the percentage difference from the intended amount. Guidelines of the United States Pharmacopoeia of 24 and National Formulary, British National Formulary 19 supplement 1 indicate each tablet shall not less than 90% and not more than 110% of theoretical calculation weight for each unit. So when you are seeing the content by means of UV spectroscopy or by means of titripetic method, complexometry or iodometry or gravimetric analysis, whatever may be the analysis, if you are doing, the constituents should not be not less than 90%, not more than 110%, and also there is some limits will be given for every standard books According to that, it has to be followed for each and every monograph for every essay. So this is a part of the tablets. I just finished this area. Only I have come to what is definition and also in process checking some of the parameters which we have discussed. And next class we will go for the new we'll go for instrumentation or manufacturing. Let me see what we will be discussing on next Saturday. So thank you very much, and we will meet in next Saturday. God bless you.